Welcome to our webinar on investing in fusion. I'm Kim Moore, Deputy Editor of Global Corporate Venturing, and I will be moderating today's discussion. So today's webinar is asking the question, is it time to invest in fusion? We're asking this question because although the idea of fusion has been around since the 1950s, it's really only in the past few years that we've had technological breakthroughs that have made the possibility of commercial fusion reactors a reality. If fusion technology does become commercialized, I don't think it's an exaggeration to say that it would be a huge step for humanity, because it would provide cheap, plentiful, emissions-free baseload energy, and it would go a long way to helping us meet emission reduction goals. But there are very large technological challenges to overcome before fusion becomes commercialized. So it's a really big gamble for investors to commit capital to this technology. On our panel, we have two corporate investors and two fusion startups. We have Tina Tosa Huang, who is the investment director at TDK Ventures. We also have Wolfgang Seibold. He's a partner and CFO at Hitachi Ventures. And then on the startup side, we have Oded Gorlavi. He's the CEO and co-founder of NT Tau. NT Tau is a fusion startup based in Israel. And Christopher Murray, he's the CEO of Type 1 Energy, which is a US-based fusion startup. And I should mention that TDK Ventures is an investor in Type 1 Energy. So before we start the panel, I just have a few slides to go through about the state of fusion investment. So fusion investments in fusion companies really started to gain momentum in 2019. It reached a high of 2.4 billion invested in 2021. And that year, there was a very large 1.8 billion funding round in Commercial Fusion Systems, which is a US startup, which explains the spike in investments that year. And then since then, there have been increasing numbers of investments in fusion, but at smaller funding rounds. Historically, fusion technology has been concentrated in North America and Europe, but in recent years, VC-backed fusion businesses have emerged in other regions, such as Asia and the Middle East. And in the past few years, VC investors have funded more early stage technology compared with later stage. I just wanted to mention that during the panel discussion, you can submit questions. There's a button on the Zoom platform for you to do that, and we'll try to answer those when we can. All right, so I'm going to start, first of all, with asking Tina, why has TDK Ventures chosen to invest in fusion, given that it's a very big gamble?
Well, thank you so much, Kim, for the question, and thanks for having me today. So TDK Ventures, we are an early stage deep tech fund that is investing in disruptive technology that could disrupt our corporations, right? And in terms of the energy transition investment thesis, fusion fits very well. If we are looking today on the energy use and global greenhouse gas, you will see that 75% of the global greenhouse gas is coming from energy use. And we are a big supporter of renewable energy like wind and solar. There are several factories that has converting from natural gas to renewable energy already. But if we are looking into the future, there are things to be desired. Things like how do we take care of the intermittency, because renewable energies come with intermittency and a lot of land use as well when you're talking about solar. At the same time, when you look at nuclear, this gives enormous amount of power, very energy dense, But nuclear fission is the area that we decided not to invest because of several problems related to dealing with the nuclear waste, end of life, and so on. But fusion, on the other hand, is one of those that could present a silver bullet for energy generation, low carbon, very energy dense power, and no long-term radioactive waste that you mentioned. But these would have not been an area we invested 10 years ago. But recently we've seen a big technological advancement in the field, and that's one of it is enabled by the high temperature superconductor. So we feel that we're at the cusp of a big inflection point, and we look at it that if we are to invest, we're going to invest in technologies that have de-risked the technical challenges, and then we would fund the company to take this to commercial by reducing the engineering risk. And that's how we decided that after doing the deep explorations, that there are certainly technology that is close to break even and can be scaled to commercial power plants. So that's how we ended up making the decision.
Tina, could you just go over what exactly is the the strategic fits for the parent corporation?
Yes, for TDK Ventures and TDK Corporation, we are very well known to supply the general electronics components to energy generation, whether that's solar and wind. And for fusions, we've been supplying things like power supply and capacitor banks to several international projects, as well as the fusion startups for the past 2 decades. So we've seen that this is an area that is very active. And as a corporate, you want to work with the startups so that you know what's coming next in the next 5 to 10 years wave, so that you develop the future product that aligns with the mega trends. And this is a very strong fit and very strong mega trend that we're seeing, and it's becoming real, more real each day.
Wolfgang, could you talk about why you've invested in fusion?
So we have not yet invested, but we are about to invest. So the discussion comes at a good time, and I'm actually excited to learn about also opinions around the table. So quickly on Hitachi Ventures, we are the venture capital arm of Hitachi Group. We are a dedicated fund with a very quick decision process and governance, very independent governance, and we invest into big topics that actually are of importance to Hitachi. And I can name 3 effectively. The green transformation, which means to move away from fossil fuels into renewable fuels and others, and to effectively make industrial processes less CO2 heavy. The second is the digital transformation, which is effectively digitizing all kinds of industrial processes. And the third is what we call social transformation, which effectively also goes into directions of future of work and many other aspects. For Hitachi, the nuclear industry has always been a very important industry. You may know that Hitachi is a provider of nuclear energy plants and actually has been on the forefront of technologies on all aspects, be it on reactor designs, like, for example, in small modular reactors, in advanced fuels, in field services, and even in decommissioning of nuclear plants. So strategically, this is an important topic for the group. But of course, we are a fund, so we look at this more from an opportunity perspective and also ask ourselves why. And from an opportunity perspective, I think Tina has already set the scene. Effectively, in order to allow the green transformation, we need a baseload energy. And where can baseload energy come from? I think fission to some extent has reached its limits and is dependent on natural resources that are hard to get, while fusion probably can, as she said, be a silver bullet. So the bigger question for me is why now? And why am I asking this question? 30 years ago, I studied astrophysics and nuclear physics in the UK, and I learned that we're about 30 years out. Honestly, we're not there yet. So the question is, after all those delays, why are we now at the time when really fusion is going to take off? And of course, also Tina mentioned there have been a lot of breakthroughs recently. NIF reported the Q greater than 1. They also reported controlled burning plasma. We have seen from tokamak reactors like K-Star or the Oxford reactor plasmas that burned at very, very high temperatures in the hundreds of millions of degrees for relatively long periods. So the scientific advancements have been actually quite good over the past few years. But I do think an even more important transformation that we're seeing at the moment is the democratization of the fusion technology. Why am I saying that? On the one hand, the turnaround of reactor designs has drastically accelerated with the upcoming of new technologies, like, for example, new simulation technologies, HPC compute in the cloud, and that effectively those resources become accessible to even startups and young companies, and not just to large, heavily funded international projects. Also, HTS materials become available, and additive manufacturing may accelerate the build of complex reactors. And we have seen significant funding coming to play. Not just the venture funding that you mentioned earlier, but also public funding that we're seeing increasingly. And that actually has started a spree of startups that come with totally different rules of the game, that do their turnarounds much quicker, simply because they have to, because they would not survive the 20-year life cycle that typically an ITER project or others have. So this, to my belief, actually is maybe the even more important factor in the commercialization of fusion technologies. The fact that it's now becoming available to young, nimble companies, and some of them we're speaking today, that actually may really turn it into reality.
And also there's lots of different types of fusion technology, right? There's tokamaks, there's stellarators. So can you mention which technologies you prefer, and why you've chosen that particular to invest in those particular areas?
It's a great question, and it's a very difficult one. To be honest, we looked into effectively all technologies, and most of the technologies are still under development. So none is commercially proven yet. Therefore, we all look into the same glass balls. But there are a couple of aspects that actually made us convert to stellarator technologies. One is the stability of the plasma, the use of more or less constant current, and effectively, therefore, less kind of critical operational modes that we see for the stellarator technology. And second, we also believe that this kind of stability of the process, and it has been proven, for example, by Wendelstein 7X, that actually probably will be the faster route to a full commercialization. We see, of course, tremendous results also with inertial confinement, where actually Q greater than 1 has been achieved very early on. It's just that the way to a long-term viable energy supply will be a much longer and harder one for those inertial confinement technologies. And we've seen with tokamak that simply the stability of the process has always been a challenge. So this is why we have converged to stellarators at the moment. Of course, we can be proven wrong, but for the time being, we believe this is has the most realistic roadmap.
Tina,
And
could you
yeah.
also talk about why you've chosen, because you have also invested in a stellarator technology. So why did you choose that as opposed to, say, a tokamak
Yeah, I
investment?
think I echo what Wolfgang just said. When we look at the technologies that very near the energy break even and net gain, there are 4 of them: the tokamak, the stellarators, the inertial confinement, which is a laser approach, and then another one called mag lift. These 4 are very close to break even, and we pretty much hone in on these because we believe that those that are still so far away from the break even, they need to de-risk their technology first, and these could take several decades. And then among the top 4, this is the only approach that provides continuous power plant. And if we are talking about the needs for the world to move away from coal-fired power plant, which is 27% of global greenhouse gas, we need to find a solution that can be as good, providing baseload steady energy to the grid. For us to make a bet, it has to be compelling enough. And seeing the advancement that has come out from stellarator community in the past several years, I think this is a pretty good bet that hopefully can be accelerated because it might be the only viable approach to get us to steady base load and put the coal-fired power plant off the grid. So that's really the drivers behind our investment in stellarator technology.
We do have a question from the audience, which is sort of in relation to what we're just talking about. And it's someone's asking, do you invest in just one fusion company, or do you find that you could invest in several different types? So do you, Claire, could you maybe answer that? Tina, would you start?
Yes, I think this is like really the fun strategy, right? For TDK Ventures, our approach tends to be investing in what we believe is the king of the hill. So we tend to invest in one company in particular applications area. So for the fusion approach that would become the power plant, I think this is the bet that we have made. But maybe, you know, in other applications of the, I don't know, maybe for in the future, if there's a reason to believe that fusion can be applied for other applications, then we may invest in other areas as well, medicals and whatnot, or a company that do address other infrastructure of fusion that you may need, like the balance of plant, then that could be a separate consideration. But in terms of the fusion technology that's going to become the power plant, I think we have a solid bet here.
Christopher, would you like to chime in there?
Yeah, I'm Chris Mowry. I'm the CEO of Type 1 Energy, but I also am the chair of the Global Fusion Industry Association. So I guess my comment here really comes from my second role here, and that, you know, one of the things we're really seeing accelerating these days is the maturation of the fusion industry. And one dimension of that is the emergence of what I'll call tier 2 companies, right? So, you know, your question on one level, I think, presupposes the fact that every fusion company is trying to develop their overall integrated solution. And that has really been generally true until the last few years, where you've seen the emergence of companies like Kyoto Fusioneering that are not trying to develop an integrated fusion solution, but to Tina's point, really focused on being a supplier of key technology elements, right? And in that regard, one can certainly imagine an investor investing in both a tier 1 company, which is really making a bet on the actual architecture of the solution in totality, but also separately making an investment or more than one investment in tier 2, you know, the supply chain of fusion, which as the industry grows up is really emerging now as a critically important dimension to commercialization.
Wolfgang, would you like to talk about?
Yeah,
investing in more than one? Mhm.
Thanks for the question. We had a very difficult discussion about that because we typically also have the philosophy of not investing into competing technology companies. However, for the fusion space, we came to the conclusion that we want to actually place several bets. And it could be, like Chris just mentioned, into, say, complementary technology pieces, but it could even be into more or less similar companies, because what we expect building a nuclear fusion plant will be a very big undertaking, and there will most likely be consortia of companies coming together, and maybe some of the people that we today see kind of in their concept compete against each other, but maybe eventually they will work together, which is why we have decided to do a couple of those bets in the first place.
I want to bring Oded in here just to talk a bit about your technology, because you've got quite a unique kind of approach to fusion technology. Could you just speak a bit about your startup and
Yeah, so thank you very much for having me here, and it's an interesting panel around investment in fusion and also technology. Anti-Tau is Israeli-based, as you said and presented, and we're in the area of magnetic confinement, similar like stellarators and tokamaks. We're actually based our technology on a stellarator, which I agree with Tina as well and the others regarding the more stability and everything else regarding it, but taking it to a step further and realizing that density is a key in any magnetic confinement and in any system that is working. High density and high density plasma will enable much more efficiency in the output. And to get to higher densities, first of all, stellarators are better built for that. And then secondly, if we can manage to heat dense plasma at pulse mode, then we have a better solution. And what we're taking advantage of is new technologies that exist today. So some of that is power electronics, super strong power electronics that can really enable very fast heating of the system. It requires not a regular stellarator. It requires a dynamic stellarator that can actually work in a dynamic mode in which the heating and the confinement works together. And that's something that we have great breakthroughs around that. And the most important thing that we found a way in 2021, basically, to see that we have very high coupling of energy into the plasma, which enables very fast heating of that. And another very important thing about it is that it basically works better and more efficiently on a smaller scale system. So when you look on large scale systems, they require everything to be large, also time and money and cost. If everything works efficiently on a smaller scale, which is challenging, then all the process is faster, and reducing the risk, which is super essential in this process, it's going to take time. Reducing technological risk in a smaller system is much easier. Today we are finished in our third family of prototypes. We finished an upgraded prototype C into an upgraded version that incorporates and integrates the heating with the unique technology of confinement. All of these together need to play, as I said, together, to reach the required parameters at the high density that we want. It's about 100 times to 1,000 times more than other magnetic confinement systems. So I think that's the basic issue of our technology. And maybe a word on something that you did discuss earlier on the investment issue. I think we all understand that it's the holy grail of energy, and we all understand it's super important to get it to humanity as soon as possible. But I think when it's going to be obvious that you need to invest, it's already too late to be an investor in that. And the earlier you get in, the more capability you have to really be a part of the process and pushing it together, and also aligning with it. And I've seen, and there are a few funds that are focused on fusion and that are betting on different technologies. And no one really knows which technology will succeed eventually. We have our opinions. I'm 100% working in what I'm doing, but obviously as investors, there's an opportunity to look at different technologies and not only the ecosystem, but specific technologies. And I've seen funds that are doing that, and they hedge their bets. So I think that's also an investment strategy, depending on really the policy in which you're in. That's right now.
Christopher, could you talk a bit about your specific technology of type 1 energy, why you've chosen to focus particularly on that?
Yeah, well, I think I don't want to necessarily dive too much specifically into the detailed technical aspects, but just say that the type 1 energy I formed with Breakthrough Energy Ventures and TDK and Doral over the last year. And really, this was an effort to try to understand what the latest advances in the sector had created as an opportunity to do something fundamentally different. I think there have been a number of comments about de-risking. The democratization of technologies that Wolfgang indicated is incredibly important because the private sector really needs to stand on the shoulders of the decades of R&D that have been done to finish this process of commercialization. And so access to things like exascale supercomputers are incredibly important in terms of actually refining technology solutions for commercialization. So, as it relates to my company, Type 1 Energy, really the goal was to try to assemble a lowest risk pathway to commercialization by being very careful about the technology solution, which ultimately led Breakthrough and myself to select the Stellarator, but then also a very highly disciplined application of the technology architectures that had been demonstrated at scale. So in this case, for example, Wolfgang mentioned the W7X, the Wendelstein machine in Germany. Fusion machines are very complex, and when you start changing one aspect of the architecture or another, there can be, like everything else, unintended consequences. So the less architectural changes, let's call it that, that one makes, the lower risk path that you have. And I think for fusion in particular, and I've worked in many energy sectors, what's really important is to select a trajectory that minimizes risk and maximizes the utilization of technologies that are accessible to the private industry. The way you talked about Wolfgang talked about democratization. So access to things like exascale supercomputing, high temperature superconducting technologies. It's really about assembling that kind of ecosystem of technology elements around an architecture that is as mature as possible and being very disciplined about remaining focused on that. I think that's really, to me, the only way that you can create an investment thesis that is sufficiently low risk that you really have a good chance of achieving what your objective is.
We have lots of questions coming in, so I just wanted to get to a few of them. Are there any other applications of fusion aside from energy generation that you're currently looking at or excited about? Maybe one of the investors could comment.
I would say that there are other applications, like people are looking at it as a way to generate medical isotopes. And some companies are also looking at it as a propulsion system and things like that for the rockets applications. I cannot speak to those, whether it's good or bad, because I personally have not dived into it. We've been pretty much focusing on fusion as the main application to replace coal-fired power plant. But there are definitely a lot of people are looking at other applications.
Wolfgang, would you like to, or Chris? Yeah.
Yeah, I just want to supplement that by saying that, I mean, certainly there are other applications, as Tina said, but I think it's important to recognize that the front and center elephant in the room, if you will, is energy. Energy, the opportunity in the global energy space for fusion is conservatively $1 trillion a year, $1 trillion. And none of these other adjacent sectors offer anywhere near that level of opportunity, of impact on society. So for sure, there's other things, you know, medical isotopes and all these other things. And it's not that they're unimportant, but the biggest impact that fusion can have on society is to create a practical path to net zero. And that's why I think most fusion companies that I know of that are part of the FIA are really focused on that.
Another question from the audience is, how, as investors, do you undertake due diligence, given that it's a very highly technical, very complicated technology? So, Wolfgang, could you maybe answer that?
Yeah, so of course we speak to many experts in the market, and we try to triangulate what are the best approaches in the market, and also what are the best companies in the market. And at the end of the day, I may come back to an old rule that I learned when doing independent venture capital. You always have to recognize patterns. And for some technologies, typically investment time is ripe when you see several companies come up with a very similar approach. Then you better look for the best team, for the best consortium, and just make sure that you are in good company with people who can actually lift it. So yes, technology due diligence is very important, but I believe equally in the importance of being surrounded by the right people.
I wanted to ask also about commercialization timelines. When do you expect fusion technologies to sort of reach technical maturity levels? Wolfgang, if you could start with you, because you do have a closed-end fund, so you do have kind of expectations, right, for performance levels of your investments. So given that some people, you know, say the timelines could be very long for fusion, how do you make that fit within your fund's performance criteria?
Thank you, Kim. That's a great question, and also a very tricky one, to be fair. So indeed, as you said, we have closed-end funds. Typically, they have a 10-year life cycle. You can, if your LPs agree, extend it by another 1 or 2 years, typically. So that gives us until 2035 for our most recent Fund 3 that we just closed earlier this year. And that, of course, we tried to match with the predictions that we see in the market. And of course, opinions can grossly vary. If you ask the young companies, they typically claim that, I don't know, by 26 they will have first prototype reactors, and some actually say they're on the net by 2030. But if you look into, for example, the Foresight report, which has been a gathering of well over 30 experts in the market, I think there's a consensus that we will see working prototypes by the end of the decade, and prototype reactors that actually feed into the energy grid in the first half of the 30s. And then commercially viable, i.e. also from a price point, competitive plants by the second half of the next decade. So, I mean, taking all that together, we actually think that effectively it takes us not away from the timing to also the exit markets, because the timeline is of course limited by the fact, can we then successfully sell our stake to the public markets, to strategic acquirers and whatnot. So, and therefore, with this projection, we actually would expect that there will be strategic acquisitions upon the successful delivery or proof of concept of those technologies starting in, I don't know, 26, 27, throughout the rest of this decade. We may see if first plants come to effectively produce energy. We may see SPACs and IPOs in the very early 30s, and then a mainstream financial liquidity starting somewhere in the middle of the next decade. So the timeline and also the say exit opportunities, they should kind of match the fund lifetime that we have. And if we did our math, actually we came up to a relatively decent weighted risk-adjusted return projection. So it should work out, but to be honest, it is a bet, and we will not be able to neglect that. And my biggest worry is that the investment community may not be prepared for that. Typical hype cycles in the industry, be it for biotech, be it for semiconductors or for other industries, they were like 5 years long, maybe 7, but a timeline that is double of that or maybe even triple might be a challenge. So if you ask me for my biggest headache, it's hopefully the investment community is not going to be leaving the boat too quick for disappointment of say the timelines they have to endure.
And I'm going to add a little bit to that as well. I agree with Wolfgang, and we are the same closed-end fund. So we expect financial exit out at the end as well. And I think this really informed our investment decision that there is no time for us to waste in investing in concepts that are not proven. When we did the diligence, so piggyback from your previous question as well, we really focus on technologies that have a chance of getting to the break even. We're looking at the team as well. They have to be the strong team. We have to see that they have built a machine, a fusion machine that has a real evidence, been peer reviewed, that is working successfully in the past. So I think these are very important considerations when making a bet in fusion investment. And the reward can be extremely high as well, as Chris mentioned before, that this is a $1 trillion market. So in the end, when we do the return analysis, it is working out because we expect if this works, the financial returns is going to be pretty handsome. And given the timeline that we're looking at, again, I echo that we think that the first machine that's going to be connected to the grid, providing the power to the grid, is going to be in the early 35. But by the end of the decade, we think that there's going to be some working pilot plan, smaller pilot plan that has shown the performance that it is working and it has a strong potential, so that some of the utility company would be willing to take this forward and running and putting the steel on the ground in the early 30s to show that this is how the first of a kind fusion pilot that generate power to the grid works, and then the industry will hopefully scale from there.
Well, Christopher, would you like to maybe if I could ask the same question to the startups? Christopher, if we could maybe start with you about commercialization timelines for your own technologies.
Yeah, I mean, look, that's a great question, and I think the answer to that is incredibly important. And you know, again, there's more than 43 private fusion companies today, 43, and there's a huge spectrum of technology maturity there. So as you would expect, there's a huge spectrum of realistic timelines for commercialization. I mean, some of the very early stage companies have really, really interesting ideas. They're really, if they turn out to work, could be even transformational in the relative sense of fusion, right? They could offer all kinds of things that some of the more mature technologies maybe can't achieve. But I think what's really important here is that the investment community really be eyes wide open about the amount of work that needs to be done to take any given technology over the goal line. There's a huge spectrum from the timelines that Wolfgang was talking about to what Tina was talking about. I think lots of, that they have different merits, they have different value propositions, and how they line up with the fund is incredibly important to understand. And so that's one of the things I really worry about in terms of capitalizing the industry here is, there's really not one size fits all, right? And if you have a shorter life fund, you need to be super careful about picking earlier stage technologies that really are going to take a long time, right? And I think having access, what Tina said, I think is really important, and I've heard this from many investors, is having a peer review is really important here, especially when you start to assert much more aggressive timelines, because it is hard to really assess the quality of the work and how long it will take to get to commercialization without having the technology peer reviewed. So, as companies assert that they're closer to getting to commercialization, I think the bar or the hurdle for demonstrating technology maturity and organizational maturity to execute becomes different. And of course, it's a different magnitude of investment. So it's a long way of saying that there's a huge spread here. And I think everyone who's a stakeholder in this really needs to focus on being aware of the timeline to commercialization, because that informs what type of companies are investable by given funds, and I think what the metrics are around making that type of assessment.
But Ed, could you maybe jump in
Yes.
here about commercialization?
Yes,
What
for our technology, I think I first of all, I think I agree with Wolfgang's assessment regarding the basic timeline. I think that there are converging trends that we see. We discussed some of them on the technology side, and we see converging trends. We are standing on 80 years of knowledge and experiments and knowledge that has been created, and not everything needs to be invented, but needs to be relied on. And I think that these trends, and especially the way the private sector is now going in, this is accelerating the process. When we were all about academic study and academic research, this is a longer stage process. We're now with private sector going in with billions of dollars, and this is pushing across the board all kinds of different approaches, including ours and Stellarator's older versions and newer versions. And that will show, and I believe this decade we'll see some very big breakthroughs in fusion. And this is, I think, going to happen. And that's why I think the timeline is basically correct. I think by the end of the decade, we'll see a fusion power plant or a prototype that can actually create a Q greater than 1 and really bring out energy. I think part of the important thing, and I agree with Chris, that the reducing risk in this process is extremely important, and doing that needs to be able to do it with speed. And it really depends on the experimental validation that what you do. And as faster you experiment with it, the faster you get results. Nature doesn't lie. Simulation can only give you, thus far an answer. But nature doesn't lie. You do experiment, you understand what you have, or at least you get results. And therefore, I think that kind of process that is now available. In our specific case, it's even faster because of the size of the system and the way we're building it. But in any case, the private sector and the startups are moving at that pace. So I think we will see that happening. And I think we don't have time. I mean, geostrategically, we are just after COP28, and there is kind of political will, but it won't be what will change. And if we don't bring fusion in time and ASAP, I would say, then humanity is kind of doomed. So we need to really work fast on this.
Just on that, Oded, how do you speed up development of your own technology? Do you like look to outsource anything? Like how do you kind of get to those commercialization goals?
Basically, whatever we can do in-house, we'll do in-house. It's faster, usually. Depending on the specific technology, if you can do it in-house. If we can find it off the shelf, we'll take it on the shelf. That's obviously faster depending on the procurement process. But that's building a strong team that can actually create most of the things in-house makes a faster, iterative, experimental process. That's on the one hand. And whatever we can find within our strategic partners that they can push further. And I think that's part of the value of having a company like, for example, TDK behind you, or like in our case, others like Honda and other companies like that. That's a situation in which you have a very strong corporate that can enable even faster progress. So that's, I think, part of that connection and combination. I think that what will bring us to a good solution is a combination of academic, corporate and strategics that are helping, and the pace of startups. That's what will bring us to the goal line.
How do you work with your strategic investors? Could you maybe like give an example of how a strategic investor is of use to you specifically?
Yeah. So a strategic investor, obviously, other than having a grand vision and being connected to the vision of changing and solving climate change and creating energy, they bring in technology. So TDK, for example, has the ability to bring power supplies, can bring in capacitor banks and things that are needed in these kind of solutions. Honda, they're a huge player in the ability to bring and help us in accelerating engineering issues that we would like, and other strategics that can help. And what we do, at least, is we put in front of our strategic partners, these are challenges that we're confronted with. These are the ideas that we have. How can we push forward and reduce risk faster for all of us? And that's it's an open process with them. That's why they're in this, and that's why we choose them.
Christopher, would you like to comment?
Yeah, I would say that trying to be a vertically integrated solution is very hard. It is, I think, creates significant success risk, and is often not the best way to maximize return on invested capital, right? So the reality is that fusion energy is ultimately a heat source for, in the case of power generation, making electricity, right? And once you have that heat source, the rest of the process is actually commercially, more or less commercially mature. And so this strategic partnerships with strategic companies like a TDK or a Hitachi in Wolfgang's case create an opportunity for a fusion company to basically not reinvent the wheel. And I think recognizing that and having the ability to integrate the entire solution set outside of the individual company is critical in order to achieve the kind of timelines that we've been talking about, but also do it in a minimum risk pathway with really good return on invested capital, because you really want, especially the venture investors, to be, investing in the creation of new intellectual property and things that haven't been done before. And the only way you're going to do that is if you can really end up partnering closely with strategics. And so that, to me, is a critical element of success here.
Wolfgang, could you maybe just talk to how you plan to partner with your future fusion investments, to help them on the journey towards commercialization? are you planning any kind of partnership there or work with your investment?
Yeah, thank you. As I mentioned, Hitachi is a big EPC. Hitachi effectively has been spearheading and also working on multiple technology approaches to nuclear energy in the past. And such a fusion plant will be a big project where the reactor design is one side of the coin, and there are many other aspects to it, including the connection to the grid, including maybe downstream applications and whatnot. And of course, also things like taking care of local regulations, local safety considerations, and so on. And I do think that there is actually, the fusion space should be a pretty good place in which startups can really successfully work with conglomerates who have been there in the past, who have the relationship to the local authorities and whatnot, and who simply can pave the way to commercialization. Of course, it will go hand in hand. So it's certainly also going to be important to find the right ways of working together. But I do think working in syndicates here is a win-win.
Tina, would you like to maybe just comment on what role you play as a corporate investor in helping your fusion investments on that journey towards commercialization?
Yes, we are definitely learning to be as helpful as we can. The power supply capacitors are the obvious ones, but we are learning new things every day that, oh, they need like magnetic components. Oh, they need to handle super low temperature and some super high temperatures. So we've seen that there are so many new areas and applications that we've never seen before, and we want to learn and develop other electronics components that would be useful for startups in the future. And as we go around and talk to other corporates, we also learn that each and every one of them can bring in, new knowledge, new capabilities. So I really would like to encourage all of other CVC fellows to, reach out to Odette, to Chris, and learn more, because this is a really new mega trends, and they're gonna need new materials, new components, and all kinds of engineering capability to handle the requirement that's gonna come when the fusion industries grow. So I think this is the area that I learn a lot. We learn a lot as the organization, and still a lot of work to be done in terms of the collaborations in the future.
You bring up an interesting point there about like infrastructure to bring commercial fusion reactors online. What's the biggest hurdles there in terms of infrastructure? Like, what do we need to build for commercial fusion reactors to sort of come online, in the next 10 years? Would you like to comment? Someone, Chris, maybe you could comment there.
Yeah, well, again, the answer to this is a not one size fits all, because there's a really broad spectrum of technologies, right? The commercial infrastructure that's needed for inertial laser fusion is totally different than for magnetic confinement, whether it's tokamak or a stellarator. So for magnetic confinement, one of the big areas has been the access to high temperature superconducting cables, cable technology, superconducting tape for these magnets, because that's really the key for taking magnetic confinement fusion to practical commercialization. And so there's been a lot of anxiety, I think, in the fusion community, even 3 years ago, about whether there would be enough supply of this kind of material to support commercialization. I think we're generally very happy with the number of industrial companies that are coming into the sector in that regard. There's a couple of other areas that also around materials and minerals, tungsten, some rare earths like palladium that are important for tritium processing that need to be brought forward. But really, you know, and if I go back to Tina's comment about juxtaposing fusion from traditional nuclear power, and I was in that sector for a long time, you know, one of the challenges in nuclear power is the supply chain has very tight regulatory and quality restrictions on it that make the supply chain and the development of supply chain for new nuclear technologies very, very hard. One of the advantages fusion has is that it is regulatory light. And so, you know, being able to tap into existing technology supply chains, like the power supplies that Tina was talking about, you know, that were originally developed for other energy technologies, is relatively straightforward. And so I don't think, in my view, that broadly speaking, certainly in magnetic confinement sector, that is a major issue. And that is, to me, one of the reasons why I am optimistic that fusion can really scale to the degree that it needs to really help this energy transition. So it's a great question, but the answer to it really focuses on one of the really important value propositions of fusion, which is that fusion, you know, at least a core set of those technologies really should be ready to scale in the 2030s. And one of the reasons is because the supply chain, if we continue to pay attention to a couple key areas, like I mentioned, ought to be there to support that scale up. And so from an investment perspective and trying to think about how that technology achieves large-scale market adoption, I think fusion's going to have a much easier time than some other technologies like advanced nuclear.
We've run out of time. I want to thank the panelists for a very insightful discussion. So thank you for your time. Just to wrap up here, just wanted to just talk about we have a new webinar coming up in January. It takes place on January the 10th, and it's about CVC portfolio management. How can corporate venture teams partner with startups in their portfolio to drive financial performance? We've got some upcoming events next year. Our first is our inaugural GCV Connect conference in Bangalore, India, which is taking place at the end of January. And here are some upcoming GCV Institute courses. You can find out more about these courses and events, as well as read in-depth articles about corporate venture on our website, globalventuring.com. Here's my contact details if you have any questions about the content of today's webinar. Thanks again to the panelists. Yeah, thank you for joining us.